Oh, that's enough of the intro music. Alright, thank you for the tester. Check my prime loot. Done. You can hear the echo, it's coming from the other computer. Right, let's switch that sound off so you don't get the echo. There you go. We're here. Welcome. Welcome to the Programming Games Club. If you want to skip forward to today's subject, watch for this screen to come up. Shaders. That's today's subject, what I'm going to talk about. But first of all, let's have an update. Where should we start with the updates? Shout out! We have a shout out. Let's start on here. So this is YouTube. Obviously you're watching on Twitch, I know. But this is YouTube where Fraser Sharp exists with 34 subscribers. That's way too high. It should never have got that high. My apologies. I don't wish to be popular. Yes, joined 2020, and this is 2 years later. Well, 1.5 years later. Nearly 2 years later, and I really haven't tried to grow this channel, and I won't do so. I've just added my details in case you want to contact me on the About page. On the home page, we have updated. We have Wednesdays. Stop speaking to me. We have Wednesdays. It's already got 2 views. And you didn't even know it. Well, somebody obviously knows I've uploaded it. But there's a problem on the uploads. Look at the previous. It's got 20 views. That tells me that by accepting the feedback, this channel might become popular, and that's dangerous. And here's why it's dangerous. Because I've said a few things that the industry didn't want me to say. This is not a conspiracy theory. This is nothing like that. They don't want certain things in the public domain. They have copyrights on intellectual property, IP, and that is valued in the millions, billions. It's money. And if I give that information away freely without copyright for you to do what the hell you like with, their IP becomes worthless. I have become very dangerous. So I've got to be careful what I say. I accept that. And to show you that I'm not messing you about and that they are going to try and shut me up or get hold of the intellectual property which I could provide. In other words, can I improve upon the IP that they already hold? We have this. This is a Virgin Media mailbox. Okay. I have 3 mailboxes. I have the one here, which is my private mailbox I'm giving to this channel. I have a general mailbox which is for junk mail, the one that I use in general across the internet, where I expect to get spammed. I have a 3rd email address from a business which I closed down last Christmas called Amber Skies, and it's amberskies@virginmedia.com. I've just received at 11:30 today an email on my Amber Skies business account. This is Amber Skies, okay? The people. Okay, I'm letting you see my inbox. I have no problems with security. I've cleaned this inbox, don't worry. Look, you can tell. it still does hold some business bits and pieces which I have to hold. But let's have a look at this email. Shall we? Can you see that? This is going to be a bit crappy, isn't it? Can I zoom in somehow? Is there a... No, there isn't. Is there an Alt? No. Is there a Control? Oh, there is. Here we go. Alrighty. Cooking. I'm going to let you read one of my emails. This is from Jenny Cade. Thank you, Jenny Cade, for sending this email to me from ioassociates.co.uk. Whether ioassociates.co.uk is real or not, whether this is a scam or not, is irrelevant. The relevancy is that I received this at 11:30 today. It is now 11:59. I think it was today. Does it give me a date? No, it doesn't put a date on it unless it goes... Yeah, okay. Oh, dear. Good morning, Fraser. Spelt wrong. Please note, if you're going to contact me, please spell my name right. It's an alias. It's not to hide my true identity. I've already given that away. I think it's come up on the screen plenty of times during these streams. You could have used my real name. Just a quick one today. I'm excited to be... This page isn't responding. Okay, I think I've broken Windows. Good, I tried to read that out loud for you. I'm excited to be working with a multinational tech for good company. Your work will have now, obviously, I'm not... Oh, go away, I don't care. No, you're not going to exit, not whilst I'm trying to stream. Tech for good company, your work will have tangible impacts, improving the health and well-being of people around the globe. As a result, I am looking for someone passionate about tech that wants to do something good through their work. Now that ticks all the boxes for me. What they don't know is that I work for the British government. They can't employ me. Key tech includes C#, .NET and some form of desktop development hardware experience, e.g. WPF, the Windows platform, WinForms, embedded systems engineering. This means that they are web designing. You'll receive a salary of up to £55,000 a year, I suppose, or maybe that's a day, I don't know, and will take on a hybrid approach, visiting the Salford, Manchester office once a week, which is impossible for me. I'm disabled. They should know that if they'd watched any of the streams. Our client isn't currently providing sponsorships, so right to work in the UK is required. I have no right to work in the UK, as I'm semi-retired disabled. Please reply now for more information, ideally with your up-to-date CV attached. I don't have a CV and I will never have one. Thank you in advance, Jenny. There's a footer and it's a consultant, IO Associates. And basically, these are people who are trying to register qualified people as consultants so they can farm them out to other companies and charge large amounts of money. Obviously, you get your cut. This is a typical business plan. In other words, they do bugger all and leech off your abilities. That's fine. I don't mind that business plan. That's probably a good one. Okay, I get the message now. Exit page. You can't even do that, Windows. Thank you. Goodbye. So, if I reply to that, and agree to it, then everything that I say on this channel cannot be about what we want to talk about. I will sell the intellectual property of this channel to that company. Something's broken. Oh dear. Yes, something's broken. I opened an email. That's okay, I'll delete it. I don't need that to delete it. So, problems. Do we sell the channel out? Do I stop broadcasting? Do I join a company? Well, obviously not. Where's my phone? You can't see this, and you don't know that I'm actually going to do it. Multimedia. No, I don't want multimedia. Google. That'll give me AMD. Can't do it from here. I have to do it from a separate computer that's not online. Okay. Alright, so we can use this computer. We can use the monitoring computer because nobody has access to this. I've got a pling here. Why have I got a pling here? Views is going away on the... oh, right, we've got something else to talk about here. How do I get to my account? Oh, right, I can get to it from here, can't I? There we go. Jenny Cade. On a secondary computer, I could plug in a camera, show what I'm doing. I'm not going to. You are deleted. But thank you for your interest. It's appreciated. Right, let's continue with the update. I've just spotted something else we need to talk about. We can talk. I can show it on here anyway. Let's have a look. Home. Let's go back to Fraser Sharp. Don't you dare play. You are playing. Stop it. I keep stopping you from playing. Will you please remember my preference? YouTube, stop being stupid. Wednesdays has been added. It's already got 2 views. It was added 20 hours ago. We have feedback. It's up here. The feedback is on here. Here we go. And a small conversation has happened since Wednesday. Shout out to Karim Hamdallah. Thank you for your contact. You are quite right in everything that you have said, and I totally agree with everything that you have said. Maybe not in the way you said it, but that's irrelevant. That's not my choice. This has been upvoted twice. Okay. Basically, this comes down to a statement made by himself, which is here. And you probably can't see this. Damn. How do we make these things bigger? It says 100%. Here we go. Zoom. Well? Zoom. Control. Oh, you beaut. Okay. I can't read this. Okay. I hope you focus more on how architecture, created with examples, for each component, not give a game engine, which means do not focus upon the game engine side of this, but instead split things down into components, which you could put together like a jigsaw. This was all spoken about Believe it or not, this came out before I released. Yeah. Well, this comment is not on the one that I've just released, which is, funnily enough, coincidentally, talking exactly about this kind of thing. This person hadn't seen that Wednesday's stream, didn't have that information, but it would seem that we were thinking along the same lines. And read it, lack of theory explanation, and boring way to read me your code. Okay, so not give a game engine, and I'm trying to decipher this, sorry. Read it, lack of theory explanation, and boring way to read me your code. I can only give theory. We might have a problem with that last bit, but we'll try and do our best. You waste a lot of time every day. Why you don't write code from scratch with more explanation? Right, that is the bit. That is the question. That's what we're going to do next week. Writing code from scratch has now just become next week. Let's add that. You see, I do take a lot of interest in what people actually want. We haven't started shaders yet, don't worry. And no, just open it, Windows. So I want that sentence. Where did you go? Come back. Code from scratch with more explanation. Perfect. That is beautiful. That is golden. Right, code. And that's what we're doing next week. We're going to write your first ever computer program that you ever write. I think I've got that right. Make sure that you always get your feedback correct. It's important. It's more important with more explanation. I think I've got that right now. Okay, brush. The reason I have these blackboards is because I can't remember anything. Write code from scratch with more explanation. So this is what we are doing now. We finish it today, actually. Write code from scratch with more explanation will be next week. I've got a free weekend. We can do what the hell we like. That's going to be fun. God help us all. Giving me free hand. Whoa. Okay. We're doing OpenGL Foundation code. We're doing shaders. I think I've covered everything, have I? Except what we just found out about Twitch. Okay, everything's up to date. Big thank you, Karim. That really does matter. Because it's going to help. And that's what the industry doesn't want me to do, I think. I better be more careful about what I say. Okay, Twitch here has got this here, views. It's got a little mark on it. Views is going away on April the 14th, 2022. We want to make sure the stats you see are an accurate representation of your live audience and engaged community. This stat, as it exists today, doesn't meet this standard. In other words, they don't want to recognize what you have already achieved. They want to recognize what you currently achieve. This is a way of manipulating statistics. Any statistics that are created about you online can be manipulated in any way, shape or form to say whatever the company who owns those statistics, in this case Twitch, to say whatever the hell they like. This can mean that they can put a value upon your channel, a monetary value. This is an attempt to value your channel. They want to make sure that they are valuing your channel as it currently stands. This makes pure business sense. But it takes away your achievement. What you have achieved historically. Learn more here. I'm not clicking on that. I don't care about that, and I don't care about the money. Twitch, you can do what the hell you like. I can close this account whenever I like. You are not important to me. But thank you for your interest. Shaders. Today's subject. Let's start. Update's done. I think we're good. We've been through everything. And hello, viewers. We've got viewers. This is untrue. We shouldn't have viewers. Let me just close that. It's on my other monitor as well. Alright, we're live. Just checking sound. Check, check. We are good. Shaders. Welcome to Shaders. Today's subject. If you wanted to skip, I should have said that at the beginning. If you wanted to skip, you could have waited for this screen to come up and then joined us at this point. Fine. I'll try and do that in future, because we're going to probably start each one with some kind of update of where the channel's up to. I want to show you that I'm not going to sell you out. I don't want the money, and I don't want your subscriptions. And on YouTube, if you do subscribe on the YouTube channel and start making it popular, fine. I'm not going to monetize it. I'm not going to join YouTube. I don't want to be a part of that. It's there for you. It's not there for me to make money out of. Let's get that straight. Shaders. Here's your module. Where do we start? We start with a little bit of research, obviously. What are shaders? Why is this important to us? Well, funnily enough, if you're going to be doing OpenGL in any programming language, you will come to the point where your graphics card will want to run a program on the data that you are providing it. Answer: it's a program. No, it's not a program. Yes, we'll call it a program. This is a very basic answer. A program that runs on the graphics card. In fact, the graphics processor unit. I don't like abbreviations, so I'll spell it out. In this case, it's a graphics card. On a laptop, it'd be integrated graphics chip. On a phone, it's integrated graphics. On small devices, mainly integrated graphics. But it's still there. It's still part of the GPU. It's actually on the GPU and part of it. The GPU has its own memory. It is its own computer. Yeah, a GPU is a computer. The CPU is your central processing unit. That is the central processor for your computer. The GPU is the central processing unit for your graphics device. And you can run programs on it, just like you can run programs on your computer, because they're both computers. Two distinctly separate computers working together with an end goal. And the graphics card produces graphics to the screen. It's an output computer. Doesn't really tell us what shaders are, though. It's a good enough definition for us. A program that runs on the GPU. That's fine. Absolutely fine. So we're going to stay with that because we do not want to get things complicated. How many shaders are there on a graphics card? Lots. There you go. I counted it in troll count again. There's 1, there's 2, there's lots. There's lots 1, there's lots 2, there's lots more. We're going to pick 2. So, how are we going to approach programs that run on a computer attached to our computer? Well, we are going to need 2 things. I can't go that way, so we'll go this way. The next question is, we're going left, aren't we? You're right, okay. It's easier to go to the right because I'm right-handed. Or am I? Good question. How to program these shaders. The shader which is important that I am not going to mention today or program is called a compute shader. It's a it's more important than the ones that we're actually going to do. We're doing OpenGL programming, so I'm going to do 2 of the basic OpenGL ones. There's also another one called a geometry shader, which we're going to skip. You're starting to understand now there's more shaders on your GPU than you are going to initially know about. Okay, as long as you're with that idea, we're okay. There's more in there to research for you, alright? So let's move you to here. So we're moving to the left. We need to know 2 things. What is the program's name? And which language are we going to use? We need to know its name so we can access it. so that we know where it is. We can find it within one of those lovely tables that we were talking about on Wednesday that graphics cards use as a state machine. There will be a list of shaders or shader names. Well, no, actually, there is a list of shaders on your GPU. They will be enumerated within the driver to a human readable name. They'll be stored in a table of just numbers. There's no need to store it in a table of words. It's a computer, for God's sake. It doesn't understand words. They will be enumerated to something that we can probably use, recognize in human language. So there is something in the driver which is going to convert that over for us. So we're going to be able to find the program's name within the driver. Which language are we going to use? Okay, so the program name. We are going to have 2 shaders, so 2. We will use 2. Programs. I'm not going to call them shaders at this point on purpose. A and 1 or 2. So we are going to use. I don't know how to do this, but which is vertex. We've already talked about the vertex. It does not mean position. And fragment. A fragment is the thing that is created before the depth test. That's the best way of thinking about it. And rasterization. We've talked about this already. A fragment is a possible pixel. If it does manage to be drawn to the screen, it becomes a pixel. This is the last part. We create the fragment and let the GPU then decide using things like depth testing, blending, whatever. We let it decide whether what the data that we have generated actually gets displayed or not. If a pixel has not been displayed, or that decision hasn't been made by the logic on the graphics card, that pixel is called a fragment. Fragments get discarded, or they become a pixel. There's only 2 options. It's binary. The vertex shader is where we shall calculate the position of this pixel fragment. Damn, this is going to get confusing. The vertex shader runs once per... This is important. Have I got space now? We know what a vertex is. It is not a position, it is a full set of data that describes a certain point in space, in 3-dimensional space. This will run once. This is the last theory one you're ever going to get as well. Next week we don't do this theory. Oh dear. Runs once per vertex. And the fragment. Possible pixel. I say possible pixel. To be, because it's future tense, displayed. Okay, I think that does that. Okay, we're spreading out a little bit here, and that's where we are right now. So we're going to use the vertex shader, the fragment shader. These are two programs that can be run on the graphics card. The vertex shader runs once per vertex. So if we have 3 vertexes making up a triangle, it runs 3 times. The fragment shader will run once per possible pixel that is enclosed by those 3 vertices. So for each 3 runs of the vertex shaders, because we are going to be using triangles within OpenGL, so for each 3 of those runs, the fragment shader can run anything up to 1,000,000 times. In fact, no, we'll calculate that. That was just a general dismissive statement. We'll look at that properly. Let's give you the truth. What is the size of my screen? What is the maximum possible times that fragment shader can run? Let's do 1080p, it's probably easier. We need a calculator. Have we got a calculator? Oh, we have! Cool me. Go me. 1080p is... I don't know. Why the hell would I know screen resolutions? I'll need to look on a 1080p machine, won't I? Settings. Settings. Display. Can I have display, please? There it is. Display. Resolution. 1360 by 768. Thank you. That's all I needed to know. So, that's not 1080p. I've got a monitor here that isn't 1080p. Oh, cobblers. Yeah, this is the display that I'm on. Where's 1080p? There it is. 1920 by 1080. Is that the only one? Make sure I'm right. Yeah, I have to look things up. You'll get used to it. 1920 by 1080. 1920 by 1080. 2,000,000 times. If I place one vertex off the screen upwards, so far, and one to the bottom left, so far, and one to the bottom right, so far that the actual triangle that we make will cover the whole screen. Literally every single pixel within that triangle, because we're too close to the triangle, covers the whole screen. Then the fragment shader will run in 1080p 2,073,600 times. And we ran the vertex shader 3 times. Let's put these numbers in, because it's relevant. Just stay there, it's okay. You'll be fine. If a triangle fills the screen. Vertex runs 3 times. Fragment runs 2072 073600. So where would you prefer to put the most of your calculations for programming 3D? Because what are these shaders there for? They are there to do those calculations which we humans don't want to do. We don't want to do the maths. Our graphics card has been hardwired to do that maths. So we use it to do that maths. Why don't we do it on the CPU? Because it's too slow. We're running about 5 gigahertz. Ooh, that's not gonna happen. That's 2 gigahertz right there. And this is only for a triangle. We want to do a full model. We want to do a full world with thousands of triangles. Have you ever noticed in a game that you get that slight stutter when you get close up to something? This is why. When you look closely at a model in a 3D game, there is that slight little jerk of movement, that little jutter, that little lag. It's called graphics lag, I suppose. It's where your graphics card suddenly has to go into overtime to get those triangles made so that you can see them. And that fragment shader is where it's at. There's the time. It has to do that very, very quickly, and it does. If you imagine your graphics card has a lot of little GP, well, no, it doesn't have GPUs. It has a lot of little processor units on it, hundreds of them. So it's going to do these in parallel. There's no way it can do it one after the other. That would be stupid. Your CPU would have to, but your GPU is specifically wired to do these calculations in parallel, using lots of processor units. So if you've got 1,000 processor units, it only takes 207 times. And that's how your graphics card works, and why it doesn't need to run very fast. Because it doesn't. It'll run at about 1.1 gigahertz, 1.2 gigahertz if you've got a very fast one. But it's got thousands of processors on it. And threading. All controlled by a GPU. Yeah. So what should have taken 2 seconds on a GPU to do at 2 million only takes a fifth of a second. Maybe. Or a 60th of a second. Or less. The golden grail is 1/60th of a second or less, obviously. But you can see now how many processors, how many processing units are on that graphics card and why they cost so much. They are computers full of processing units. And that's all they do, process. The memory is just for data storage, who cares? Okay, we've understood that theory. This is the last theory shop I'm going to do. Oh my god. Language. We understand that we've got a vertex and a fragment shader. They are possibly going to be called the vertex and the fragment programs, shader, whatever you want to call them. Language. I'm not lining this up properly. Come on. Come on, blades. OpenGL is abbreviated to GL. We are going to use a shader language. They were very inventive about what they called it. SL. That is the language of a graphics card for OpenGL. It's called GLSL. You can wiki it. There's a full manual. Let's see, full manual. Yes, guys, it's our good old friends Kronos. Our standardize people. The people that made the standards for the GPU also have made the standards for GLSL, if I could speak. Which does help when you're trying to do this kind of thing. Go over to Kronos.org or whatever it is, wherever it is on the internet. Go to the GLSL wiki. I've done this research over and over and over again. I'm not going there again today. I don't want to extend this too far out. Do your research. What is GLSL? Well, it was invented at the same time as OpenGL, sort of nearly, historically, not quite accurately. And because of that, there wasn't really much around at the time that they could base the language off. But one of the languages at the time wasn't just popular. We all knew that that language was going to be the future. Every single programmer knew the language that had come along and supplanted assembly language, literally supplanted assembly language, had become or was becoming the main language of programming, and also has become the main programming language for programming languages, that this special language, and it is a special language, was going to be the future of computing. So GLSL is based on C. A-N-S-I. ANSI C. The original C. The original C had 15 command words, and that was it. I'm serious. I think it's up to 32 now after extensions have been added to it. So it's grown, it's doubled in size since its first conception, which is why I always put C17 in for 2017's revision of C instead of using C11, which is 2011 standardization, which came about when they did the rehash of the internet for version 6 protocols. The standards are unbelievable, but that original ANSI C is still valid in all other versions of C today. The core 15 commands have remained the same. C is not the commands you can do today. C is ANSI C, which is the original 15 commands. If you program in those 15 commands, you can program anything on a computer. Remember, you only need to do 3 things to program a computer. You only need 3 commands. It's got 15. Yeah, it's got 12 more commands than it actually needed. Mainly to do with variables and what types of variables you wish to use. That's what the other 12 are for. Yeah, it's that big a language. And people realised that. Programmers realised that this programming language, which was so much easier to use than assembler language, which relied on which chip you were using. Yeah, assembler language, you actually have to get the manual for the chip on your computer. Otherwise you can't program in it. Interesting. But with C, you didn't need that manual. You didn't need that complication. You were free from the chip. And that was the big enabler, the big revolution in programming. And it gave rise, at some point in our history, to GLSL and the big revolution that has happened with the graphics card, enabling us to program a graphics card to do calculations for us in any fashion that we wish. I think I've given all of the information. Yes. So let's look at it. We know what we're talking about now. We're talking about a C-based language in 2 programs that we've chosen on a graphics card called the vertex shader and the fragment shader. We have an idea of what those 2 shaders are meant to do, but we can program them to how we like. Where would you like to put most of your calculations? Would you prefer them in the vertex shader or the fragment shader? I think that's pretty obvious as well. If your vertex shader holds 5 lines of code and your fragment shader holds 2,000 lines of code, have you made the right choices? If your vertex shader holds instead the 2,000 lines of code and your fragment shader holds those 5 lines of code, have you made the right choices? because you will see something completely different on screen. And that is an actual fact. If you want to test that out after this and you are happy and you are proficient with GLSL and you know what you're doing, and this is just a talk which is just, you know, there for you, try it. Take those lighting equations out of the fragment shader, put them in the vertex shader, and then just pass the results through to the fragment shader. And then look at what you've made on screen. Watch how the light reacts to your objects. It's a visual implementation of where do you put your code. You will get an effect called faceting. And it's a very good effect actually, and I like the effect, but it's not what a realistic scene would look like. You would have glinting and facets of light, not ray traced, not doing what it does in reality, but acting a little strange. And it's this, you look it up, it's called lighting, 3D lighting, faceting. Look it up on Wiki, it's an interesting subject. But there was a lot of calculations in that lighting. If you do it in the fragment shader, you will do the lighting per pixel. Well, actually, no, you'll do the lighting per fragment. Eek. Hell of a lot of calculations. But it'll look good. And you'll have shadows moving smoothly across your object. Per pixel. No faceting. So where do you put that code? Which one of these two programs do you put your code in? Up to you. Up to you. That's an interesting number, 2 million. Oh, we haven't got a computer. Let's have a look at some programming, shall we? That's what we're here for. Oh, I've got the wrong screen open over here. How are we doing, chat? Good. There's a computer. Can we just get that phone out of the way? I'll need this mouse, because it's a different computer. Can we just pull that wire a bit? Yeah, good. Can we loop that around there a bit so it doesn't get stuck? I think we can. Will that move? Yes, it will. Damn. Okay, we can't do that. There we go. That's the computer just started up. It's on a physically different computer. What do we got? A package manager. Alright. Hi, package manager. How are you doing? Oh, Firefox. Oh, you're important. zlib. Okay. Oh, passwords. I don't know the passwords, and that's the wrong keyboard. Here, keyboard. Woohoo! Right, we have the right keyboard now. And it's pretty close to the microphone, so you can probably get my password from just listening to the key presses. I don't care. This is Linux. If anybody wants to hack it, please do so. This is only being used for programming. It's got none of my information on it. Apply. I mean literally, none of my information on it. Hack away. But be warned. When I get your IP, I will be hacking you back. And I hope you've taken precautions about your information. Building Visual Studio Code. Oh, you brute. Twitch. We're not doing. Oh, we're doing OpenGL Foundation code. Good. Right, we've got the code. That's yeah. You're okay. You can stay there. Your system is up to date. Well, thank you. Bit quicker than Windows, isn't it? Here's our code. What do we need to do? Well, we need to store a computer program, and we're going to store it as a text file, just like we store all these other ones. Can I open code here? Open in terminal. Yeah, alright, we'll do that then. Code's just been updated. Let's have a look at it. Oh, you want my password too? Well, you can have it, I don't care. I shouldn't have really put a password on here, should I? Should have just left it open. Don't need you, you're just a terminal. Blah blah blah, anything new? Pfft, who cares? Okay. Foundation.lib, here we go, we're here. Oh, look at this, .glsls. Which one do you want to do? Flat colour, texture? I haven't got a lighting one here. These are the example ones. I think flat colour's the easiest. So we'll do that one. It's only one file. Normally people would put it into two files. They'd have a flat colour.vert and a flat colour.frag. I didn't want to do that when I wrote this. God knows why I didn't want to do that when I wrote this. I should have done, really. So the two files have been joined together into one file, and I've invented a new command. These commands are not GLSL. Hash type is not anything to do with GLSL. That's something I placed in there so that when I read this file, I can split it into two. So that doesn't exist. That's made up by me. Yes, C allows you to develop your own programming language as you program. The first line you need in GLSL is hash version. You must have that as the first, very, very first line of your code. The GPU needs to know which version of GLSL you are using before it can start to interpret the commands that you have asked it to process. 3.3, version 3.3 of OpenGL is the base standard that I use. Most people today are using 4.40, OpenGL 4.4. I think we're currently somewhere near OpenGL 4.9. We might even be on OpenGL 5, may be available to us by now. I haven't checked because I don't care. So this is version 3.3. Each OpenGL version, or version for GLSL, has its own little bit of uniqueness within it, in what you can and cannot do. For instance, this is given by the graphics card. It's a variable, a static variable held upon the graphics card. It starts as GL_position. It's not my variable, it's the graphics card's. Down here though, this used to be GL color. No longer is. It got scrapped, I think. I don't know if it's in 3.3. I think you can still use GL color in 3.3, but now it doesn't care. It's just looking for an out. It's just looking for that line there. The product of your code. You can see it's in C. But it's got these weird things in it like layout, which isn't in C. Vec3s, types of variables, which aren't in C. The Vec3s, the Vec2s, the Vec1s, or floats, don't actually exist. There's only a Vec4. Everything else is an alias. And as I said before, with shaders, the graphics card will fill in the extra numbers for you. It'll put zeros, and then there's the last one, it'll put 1.0 if it doesn't know what to put. And that it will create, if you put a float in, it will create a Vec4 with the very first value as that float, and then 3 other numbers, which will be 0, 0, 1. That's how it creates a float. Effectively. Because all of the variables have to be the same size, otherwise it cannot go in parallel. It cannot compute in parallel if things are different sizes in bytes. So everything has to be the same memory size. That makes it very easy for it to manage its memory. It makes it very easy to be able to do all of these calculations, run this program in parallel, all at the same time. Clever. It wastes a lot of memory, but who cares? Memory is not expensive. Not these days. Used to be. Not now. As long as you understand that what you are programming isn't what you're getting. When this is compiled, it will be changed a lot. Oh, sugar, I just dropped everything. God damn it, hand. Will you work when I ask you to? I don't know. So, this is code. This is real, OpenGL shader code. What can it do? Anything you want. Let's go through it. This is a very, very simple shader. Well, 2 shaders. We are going to look up how we compile this, by the way. I'll show you how to compile it. And I'll show you this version of the compiler where I've added an extra command. So you can see how you can add extra commands. And how the game industry, the AAA game industry, adds the extra commands. Because the AAA game industry doesn't do this. Because the command that you're missing here, that is in C, is #include. Which means I could have written this part here in a separate file called what? Basic color .frag. And I could have had #include basic color .frag. That's what the industry does. Let's have a look at the code first though. It's standard C at this point. That is standard C. Anybody who knows C knows how C works. These are telling the graphics card the location in a lookup table for that variable. And this needs to be exact when you wish to send that variable there. I think we mentioned that a few videos ago when we were sending our data to the graphics card for the very first time for that triangle in the example. That we had to get the layout right. I actually mentioned it on Wednesday as well. I kept mentioning it on purpose because it's the most important thing about this. This part of the language is the most important. Get this line wrong, your data will drift off somewhere else, and you'll get God knows what. It's got to match your layout description within your program, has to match the layout that you create within your shader. And that includes the variable names. They have to be exact. Just as that has to be exact with that. If it comes out of here and into the next shader, in other words, it's passed through, you misspell, it won't go. It won't happen. It needs to know the exact variable that's going out, the type, and the type coming in has to match exactly. So I've got a couple of things about variables here. We now know that they need to match up. Not just coming in from us, from our program, but also passing them between the two programs that we are using here. And this is why I wanted it all in one file, so you could see both at the same time, really, I guess. So what are these? We've got a couple of uniforms here. Static variables. These are set before you run these two programs, and these are set once. They don't change. They are uniform. That's what uniform means. Non-changing variables. We use uniforms. I've used it here for the view projection and the model matrix. So I've put the view matrix and the projection matrix together and then passed that through. And I've got a separate model matrix, probably because that's saved on the model itself. And I'm passing that through separately. So we get our MVP multiplication here. It's done backwards because it's matrix multiplication. That's all to do with math. I'm not going there. I'm interested in the uniform and that it's a matrix 4, which means it's a 4x4 matrix holding floats. A 4x4 matrix is an array by any other name. Or a square of memory. A buffer. Whatever you want to call it. I don't care. The fact that it's a 4x4 matrix of real numbers, floating point numbers, means that it's a little black box of jiggly numbers that can be used in calculations, which we don't care about, because the GPU is going to do it for us. As long as we put these in the right order, the graphics card will take care of the rest. Because that's a map4, this has to be a vec4. You can't multiply by a vec3, which we passed in. And guess how we make a vec4? Yeah, it's that fourth coordinate becomes a 1.0. We didn't need to do that well, we do actually in this case. Yes, we do. If we had put vec4 there, I wouldn't have needed that. But we didn't. And the GPU would have put that 1.0 in for us. Yeah. So that can be removed by putting that vec4 there. So you can actually write these pretty much better, but I wanted to show that you could do this. You can manually do this. Yeah, it comes in as a vec3 position. Uniform vec4 U color. Why do we bring the position in here? We're not using it. Don't need it. I think that's just setting up for what happens next when you want to progress from flat color. Send a position through so you can do the lighting calculations in the fragment shader. What a great place to put it. 2 million times it's going to run. Wow. This is the most efficient shader you will ever see because most of the calculations, in fact, all of the calculations are done in the vertex shader, which runs 3 times instead of the 2 million times for this. This doesn't do any calculations and therefore is the most efficient fragment shader you will ever see. Interesting. Any questions from chat at this point? Because all I've really described is that GLSL has its own variable system for variables. That every interaction we have with these programs of passing the variables in or out, no matter whether they are a variable or a static uniform value, it's not a variable, that it's uniform, it's a value. Never ever call that a variable, because you're wrong if you do. I can get that on screen, can't I? Yes. Sorry, everything fits on screen. That's why I chose this one. It's only 32 lines of code. The rest is C. We assign. We've done nothing else. We've done a calculation. Yeah, great. But all we're doing is assigning a value from a calculation. That calculation has to be in that format to work. Get that calculation wrong, yeah, pretty goosed. But that's the standard calculation. It's called MVP, Model View Projection. The model matrix being the position, angle, and scale of the model. I can't describe the view and the projection. No, the projection is the frustum, isn't it? And the view is the camera position, angle, scale, zoom. Ah, gotcha. It's not called scale, is it, on a camera? It's called zoom. It's just that the projection and the view have been multiplied together already within the code before passed in. You can pass them in separately. That's perfectly viable. I chose not to show you that you can choose not to. You can choose how you want to code this. But you must, if you are doing 3D OpenGL, you must have that calculation to get the position in 3D space of where that fragment is located. And that's why that's a special variable, and we didn't decide what it was going to be called. That's a special location on the graphics card that is going to hold the result of this, which is a vec4. Is it? Or is it a matrix? If you type a matrix by a vector, it becomes a matrix. It's a matrix. Okay, that is a mat4. Notice that I don't know straight off because we didn't define it. It's not our variable. So it makes a little black box of jiggly numbers for itself, and you're going to use that for whatever happens, the output for this. Whatever this outputs will be compared using that output. So whatever that output is there, it will decide on whether that becomes a pixel due to whatever that is. And it will process those two pieces of data to get the final outcome. Is the fragment discarded, or does the fragment become a pixel? You can have other shaders involved. Will that slow down your program? Nope. It'll slow your graphics card down, not your program. Think about that. The bigger the programs that you create in your shaders, the slower they will execute. They will not affect the speed of your CPU. They will not affect the speed of your main program. That's why we do the calculations on the graphics card. GLSL programming is an art. It is an art form. Keeping your graphics card fast enough so that you get the frame rate that you desire from your main program. Because at some point you're going to want your graphics card to show whatever you've calculated onto the screen. So wherever it writes out the results, whichever buffer it writes them into, the back buffer it is usually called, we will ask at some point to swap that to the front buffer, what we see on the screen. And the front buffer will then go to the back, be cleared, and the process started again for a new set of data. The GPU will run on the new set of data that you give it. We can't do that swap unless the GPU has finished doing the calculations. The GPU will not allow us to do so. And that is how we get frame rate, FPS. FPS is not a measure of the speed of your program. FPS is a measure of how well in synchronization your graphics card is to your central processing unit. If they are in synchronization and running smoothly, you will get the FPS that you desire. 60 frames per second is possibly now an industry standard. It used to be 30. 25 was acceptable. 30 frames per second is normal. Have a look at the Xbox, the PS2, the Game Boy. All of those devices are 30 FPS. I haven't checked the newest versions. That research was done in 2015. I don't know if they've changed that since that time, and 60 FPS is now maintainable on a games console. Did you notice that it was only 30 FPS? You games console people? Did you? Did you really? Did you know? You were never told. So why is the Holy Grail moved? Why is 60 FPS so important now? It isn't. It's a marketing ploy. It doesn't matter. What matters is what you decide as a programmer when you're going in to program this. You decide what your goal is. The marketing people should not be deciding your FPS. But they are. AAA games are now advertising speeds of 144 frames per second and above. Why? Because we have monitors that are capable of displaying that. And it is good marketing to be able to say, you can use our program on the highest tech. That will sell your game. If you turn round and say, this game runs at 30 FPS, are you going to impress anybody? Oh, that was the front door. No, you're not going to impress anybody. Your marketing department will just push that under the carpet and not mention it. You won't tell anybody. Will they know the difference? Did you notice the difference? Go play on your PlayStation. Go play on your Xbox right now. Plug it in. Try it. Do it. You're probably on a 60 Hz monitor unless you're on a phone, which is 30 Hz. Again, can you tell? Looking at this video, can you tell? You can watch videos on your phone. Can I just go and check the front door? I'll give you a break. And I'll put the kettle on. I've just received a letter through the front door. We haven't heard from you, so we imagine you sorted out your home insurance. That'd be interesting. This is been sent to my wife. Nobody's told them that she's just had a stroke. Goodbye, letter. You are the weakest link. And no, I don't find it upsetting. Right, that's that bit over with. I think we talked about GLSL, that it's basically C. You can do any C operation you wish in here. You can also do operations which are specific to graphics cards, and there are special commands. And that can be found. Did we do any in here? No, that's the same. Oh. Yes. There's a texture command. That's not in C. It's on your graphics card though. So you can add textures. There's also a special unit on your graphics card called a sampler, which will take in a 2D picture to be used here. But you can tell what it's using. It's using the coordinates for the texture, which we pass in, obviously. That's part of our model. And the texture scale, which you don't need. That's just been put there so you can mess around with it and do silly things. Texture scale equals 1. Yeah, it should do. If you do things with that number, you can get certain effects happening, which are interesting. And of course the colour. So you can tint the texture. You don't need that either. So all you really need is texture, U texture, comma, V texture coord, semicolon. With that and the semicolon, and that line will still work. The added variables, because I want you to mess around with it and play. So that's how I'll put that on screen. The first part is the same, yeah, absolutely. No, it isn't. We added an extra variable here at location 1, a texture coordinate. And it's a vector. It's 2 floats, because it's 2-dimensional. There you go. And we just pass the texture coordinate straight through here. That has to match the in. Has texture. Oh, right. That's a boolean. There aren't any booleans, by the way, in C. So it becomes an int. Yeah, there's no boolean in C. Isn't that ironic? So our texture coordinate comes in here, and we use it here. That's fine. But notice it's a vec2. It's not asking for a vec4. So this is a very, very special command given to us by your graphics card. This is hardwired. It's firmware. And there's a lot of them. Things like mins and maxes, clamp, to be able to clamp values so that they can't go above or below a certain value, like 0 and 1. Quite a lot of things there. Let's go into the source code. Core. Which one? I don't know. Got anything to do with shaders here? We've got a shader API. We've got bind, unbind. We know about flicking the switches, don't we? The graphics card being... No. Flicking the switch. Setting a mat 4, setting a float 3, set float 3, setting an int. Shader create. Oh, create! This is how you create a shader from a file path. This is the function you need to be able to compile a shader. And ref shader create. Oh, by the way, ref means std : make shared pointer. I think it's from the standard library. Yes, it is from the standard library. Memory. Is it? From the memory standard library? I think it is, if you look up C++. We're using standard strings, obviously, because everything's in text format. The shader name, well, that's the one we want to look at here. Create file path. Who's including you? You will not be included within the core. You will be included within the OpenGL code. So somewhere here we've got a shader, which in C++ inherits from the API. And that gives us all of these overrides. So if we look at the bottom, yeah, there's quite a few of those. Where are we? No, we're not looking at the bottom. Are we looking at the top? We are. Do I put them first? How do we make an OpenGL shader? Shader type from string. GL vertex shader, GL fragment shader. Those are the enumerations from your graphics card that I was talking about. The names of the shaders. OpenGL shader, type from string, unknown shader type. In other words, I'm only looking at these two types. If these aren't found, we don't know what we're doing. That's basically what that says. That's shader type from string. OpenGL shader takes a string, a file path. What we are looking for is the last slash. Really. Why? Last slash dot blomp count. Yeah, we're reading it. We're parsing it. Last slash count. Yeah. Finding the size, how many lines. And we're compiling the shader sources. Sources are not defined here. It's defined here. So we make one source. Pre-processed shader file. We've actually got a function for it. Good. That pre-processed shader file is because I inserted a new command which is not in GLSL. Ooh. So that's got to detect my new command and remove it from the source. If it doesn't remove it from the source, we will have a shader that doesn't work. So we read the file, we process what we read, and then we compile it. So as a pre-process. We should have that down here somewhere. Read file. Read file is a standard in reading files in C, C++. Is this C or C++? C++, okay. So in, find out how big it is, and read it all in. Simple. If it can't read it, could not open file. Nothing special going on. So you find the size of the file, you read it all in to a buffer. You tell us if you couldn't do it, and then you just return the result. There's your bind, unbind, setting all of the variables. How to upload the variable values to the graphics card. So these are all the uploading of data. Pre-process. What are we looking for? Remember, we added a command. That isn't in GLSL. That's our command. We're looking for it because we need to know what type it is, and that's what that very first bit was all about. Once we know what type it is, we're fine. So we've got a failure assert. I obviously didn't trust my own programming there. That's the end of a line. Remember I was talking about the escape characters the other day? \R, \N is Windows format only. That has to be rewritten because we're on Linux. It's \N for Linux. So how can we make it generic? It's going to be interesting. So we're using tokenization, right? Okay. We are asserting that the type is either a vertex, fragment, or pixel shader. Yeah, there's a pixel shader. There's also a compute shader. I think compute would have been more valuable, but I just wanted to show there was more different shaders that you can have. Interesting. Wonder why you chose pixel. Invalid shader type while pre-processing, because we're only dealing with those three. I haven't got a pixel shader to show you. Sorry, my bad. Finding next lines, finding tokens, reading the line, return shader sources. Shader sources comes from a list of shader sources held in an array. It's an unordered map. Oh, interesting. So it's all been read out. You can read through this code. It's pretty self-explanatory. I've written it in English. We can compile it using a very, very standard way of compilation, because the compiler's on your graphics card. Yeah, it comes with a compiler, a C compiler. Funnily enough. So we can compile the vertex shader. All of this information. As you notice, GL is a graphics card instruction. Getting information logs in case of errors. That's what that if statement does. If is compiled equals false, or is equal to false, then we grab the information off the graphics card, all the logs and information off the graphics card, and we are going to print those out to the screen. Console, in this case, I guess. Yeah, that's a console. It doesn't tell us what it is, because it can't. Just sends all the information out to the console. We can then attach, once it's... what have we done with it so far at this point? Compiled. So I've compiled it using what? Oh, an instruction to the compiler that's on your graphics card. We decide to set is compiled to false. That should really be... That's wrong. That should be GL false there. Just happens to be 0, but it's still wrong. You should use GL false in programming. That's an error. It's correct, but it's still an error. And we pass through is compiled through to our information vector, IV, info vector. That's a structure though. GL get shader IV is just the information of the last operation that you've done on your graphics card. The last operation, all the results from the last operation are placed into a V table, or a table of memory. This accesses that table of memory, and we are going to place the is compiled value into this variable. And of course then we can check it to see if it has actually compiled. Our index goes up because we have more than one shader. So the first time through this it'll do the vertex shader. The second time through this it will do the fragment shader. So that will be while something. I can look at that by going down this line. Oh, it's a 4. The number of shader sources. So for each KV, bad, that's an abbreviation that needs to be corrected because you have to look it up. Where do we assign KV? Pfft. You see why you shouldn't do that? Here we go. We assign it here. It auto assigns. We make it as we go. So for each value of shader sources, we go through them. There should be 1 or 2. Doesn't really matter. 2, I think. Max length. Yeah, there's a few instructions in here. We link our program. So we attach it, we go for the index, we go through for the second one, we do the same with the second one, we attach it, and then we go and link the program, because we have to put it through a compiler, then a linker, just the same as you do with C and C++. Is linked, we check, do an error check. If it's had an error, we dump it out to the console. Once we've done it, we ask, or we remember the handle in the lookup table for that program that we have compiled. So the location on the graphics card where the program now is. This allows us to run it whenever we want by using that handle. We can then detach our shaders from the program and they can be destroyed. And those resources can now be returned. That memory can now be returned to the graphics card so that it can use it for other stuff. So that's just cleaning up. So the graphics card gets its memory back. I don't know how big your shaders are going to be. They could be gigabytes in size. Literally. Shaders aren't small. They're not small little programs that run on your graphics card. These are major industrial sized programs. So once you've compiled them, it might be better to clean up that piece of memory where you've been storing all of that information. You don't need it anymore. Get rid of it. Let the GPU have its memory back. It's a big mistake not to do that, because you could run out of memory on your graphics card if you're not careful. That would be bad. Lovely, I think then we're okay. That's how you compile them. Very simple, very straightforward. It's all detailed in OpenGL shader.cpp under the source OpenGL. If you haven't got this code, go get it. Go get it. You will find it on GitHub, on the OpenGL Foundation code at Fraser Blade Sharp OpenGL Foundation code. And it's in Foundation lib, source, platform, OpenGL. And we're looking here. Okay, all the code is here for you. Copy and paste it, download it, do what the hell you like. It's yours to use. Feel free. But remember, this has an added extra in it that we have inserted one of our own commands, which is why it's got that pre-processing thingy on it. This pre-process shader file thing here, because we added that command. You can take that out and just use 2 separate files. I'm going to go and make my cup of coffee now. Thank you. I'll be right back whilst you're enjoying this. Let me just put this up. There we go. You can see it now on screen. And I always get it to go on the wrong side. There you go. There's all the information whilst I go and make a cup of coffee. You don't need to type it. I've typed it for you. Be right back. Oh, that's heaven. It's a fresh jar of coffee, opened this morning. And anybody who loves coffee knows what that means. I'm in heaven. The smell. Oh, Poppy's here. Hiya. You coming up here? You're right down there. You want to join me? Come on then. Oh, you want to actually park yourself on me. Okay, let's just get that keyboard out of your way then, shall we? Yeah. Alright. Okay, it's not going to hit your head now. Good. Coffee is good. I think we've covered everything on shaders. We've compiled it, we just have to use it. Once it's compiled, to use it you just bind it. And then ask the system to go and render. Blending functions. Oh, there's a blending function. We could talk about that later. Set clear colour for when you're clearing the back buffer. What do you want the background colour to be, basically? Drawing an indexed. Setting a viewport. In other words, yeah, that's your scissors and everything in other languages. So GL draw. You bind your program, your shader, and then you will use a call, an OpenGL function like draw elements, depending on whether you're using index buffers or not. So it could be draw triangles, draw elements, could be draw whatever you want. But I think draw elements is probably the best thing. We're telling it what to expect, triangles. We're telling it where the buffer is, the index buffer. No, the vertex array object buffer, the menu. Where the menu of all the buffers is. So in other words, we're telling it where all the data is that we want it to run through our shaders. We've obviously set our uniform values. Prior to this, we've bound the shader program, and this does everything for you. This just says, go, do it. Do it now. And that's how it works. From start to finish, that's shaders. Obviously there's code in there for setting values and everything else. But to make this command simple, you're using a vertex array object, which is a menu of all of the buffers that we want to use. That's fine. Get index buffer, get count, yeah. And then it knows what we're using. We'll probably have bound the vertex array object as well as the shader. Where will we find that information out? That will be in your code, not in this code. So we need to go to some kind of reference, I think. It's not in here, is it? No. No. It's not here. Alright. Let's try in here. Ah, wrong mouse, get away from me. Don't need you anymore, go away. Who are you? Go hide behind there, that'll do. Let's have a look at some code that we've written using these functions. Looking for the rendering on detach, on update. Main scene on update with the delta time. Where are we? We're in test 2D layer. Wonder where our main scene is then. Huh. It's the variable. Gotcha. There's our debug on event entity rotation system. Okay, if you really need one. New scene. Okay, nothing there. That's a pass-through. Entity rotation system is only being called, so we'll have to have a look at that. Okay, we've got two quads, which are two squares. We are rotating some of them. That's it. Don't think we're drawing them. Doesn't look like we're drawing them. Ah, here's all the data for them, so we're drawing them in here. That's, as I said before, setting the layout. That's how we have to have these exactly the same. These have to be spelt correctly, or they don't work. They also have to be told that it's a float 3 and a float 2, and must match that vec 3 and vec 2 value in your shader, or it won't work. That's the index buffer, which we haven't talked about at all. That's just setting the data. What you would do here, by the way, is load your models. You don't have this, do you? This is, okay. This is not in here. Ah, here we go. Begin scene. Found you. So this isn't available to you from here anyway, from that repository. This has been collected from a different video series that I did covering this subject. You can go and watch it if you wish. So you can see here that I'm using a shader library, the flat color shader, which isn't in here. It's in Amber Skies where it shouldn't be. It should really be in here, but do you want predefined shaders which are available to the user straight off in a shader library? This answer was obviously yes at the time, and that's what we've done. So as you can see, we bind the shader. And we are setting that uniform value we're setting the model matrix up, its position, its model matrix. We've got a colour coming in here which can be used to tint. As I said before, this one is tinting. It's actually got values in it instead of 11111111, which means no tint, obviously. And setting up those uniform for the colour. You'll find it in the fragment shader. We then submit this to our rendering system for the shader, the vertex array, and the model matrix. So that is going through to our standard renderer in Amber Skies. So you can just follow it through if you like. Text shader, yeah, get texture. Yeah, this is a textured item that we're about to do. We render the textured item separately because it requires a different type of rendering. So we bind that to the on the graphics card to be used. We bind the correct shader, we bind the correct texture, and then we send that information through to our renderer. And we end scene. So we're actually making how many models here? There are 20 by 20, 400 squares. So that will be like 20 squares across, 20 squares down in a block of squares going across the screen. And we have a single textured square in somewhere, middle probably, of the screen, just being rendered out with a texture on to show that we can do texturing as well as colours. Are we altering the colours on these? No, we're not. Could do. Probably have tested that out, but that's code that can help you testing. This is all of what I've shown you is basic Pass 1, what I call pre-development code. Pass 1 is pre-development. Pass 2 is where you develop your code. Pass 1 is where you write your code. So all of this is Pass 1 code to be used as a reference, to be collected, to be stored away in files for reference, so you can refer back to it to see how you did it before, how you played with your code before, what kind of experiments you can perform on your code and play with it to the nth degree, and see whether you can write it better. Because you can. And that's the point. Whatever I show you how to write, if I was to write this from scratch right here and now, you, in the future, will be able to write it better. But you've had 40 years doing this. Yeah, so? That's not the point. I'm not a programmer. I have no idea about programming this stuff. And yet I have this code. and I've played with this code, and I know how this code works, down to the processes on the GPU and how the GPU works. That is not by accident. That's why it took me 40 years. Because I wanted to learn not how to program. I wanted to learn the system. There's a big difference between me and a programmer. A very big difference. Alright, I think we're happy with that code. This is example code. You will find it at Avengers. Let's see if we can find that code for you, shall we? It's where I put together quite a lot of this from, and we still haven't got the async loader here, but we have shown you the async loader in the Vulkan parts. So it's the same loader. It's the same file loader. We worked on it just last week. Literally all week. That's all we did. We made a tool which could load from disk something from Blender, which is a 3D modeling program, load it up into buffers and save it out just as binary. Well, that loading stage can be used in this code. You don't need the saving out into binary stage, you just need the first part, which is why I didn't concentrate on that last part, because it's the first part that's important. In fact, I think I spent all of the week on the first part and the last hour on the saving out bit, what the tool was supposed to do, that we devised. So it's that first part that you can just slot into this if you want to load a model from Blender. Pretty simple stuff, just send it through. And make sure you put the data in. Search or jump to. There we go. That one. So this is Avengers / Amber Skies. It's public. You can come and get this code if you wish. And you will find the code for the test in Sandbox. Source, including all the I'm GUI stuff as well. Did I save it out? Yeah, it's all here. So this is what I've just been talking through now. Alright, yeah, that's fine. But this is with a full, with all of the code working. This is actually, if you want to download this on Windows, it works. If you can get the library dependencies to load up and work properly. Good luck on that one with Windows. Which is one of the reasons why I'm looking at this on Linux. I don't have the full thing working on Linux, as you know. I only put this together this week to show you this. We don't have that much code yet. In fact, we have converted so far this week into generic code. This is what we have. Out of all of those files, this is all we have. You need to set an executable file. You need to set an executable in the custom run configuration. What? Says who? Huh? Run. We've got a custom run configuration. Why? Running terminal. Oh, the executable. It doesn't know. I must have wiped it out by accident. Typical of me. Twitch, OpenGL Foundation code. Sandbox. Sandbox. Okay. And the code works. So the sandbox is constructed, the layer is constructed, and of course it destroys itself properly before exiting. Right. No idea why that happened. Interesting. So that's the working code that we've looked at this week. We could today add shaders to it, but it's pointless because we've got no OpenGL here. All the OpenGL code is there for you if you wish to convert it. You can keep it in the format that is given within this library. If you're on Windows, well done. If you can get this to work, bigger well done. Yeah, it's got an SLN, Visual Studio, Community Edition. So it was done in Visual Studio. The biggest problem you're going to have with this code is Windows hates dependencies. You're going to have GLFW, ImGUI, GLM and SpeedLog. All of the other ones are inside the code base itself. They won't matter because they will compile in. ImGUI will be hell to set up if you want to do it. My advice is just take all of these that are inside of this file here, if you are trying to do this, all of these CPPs and these backends, and the backend files that you are requiring, which is GLFW and OpenGL 3, these here, and the OpenGL 3 loader, take all of those files, add them into your solution and compile them with the code. Do not use this as a library. Compile this code directly into, instead of using it as a library. So don't compile this and use it as a library. Just compile the code straight into yours. That's one way of doing it. It's a cheat, but it works. You could, I guess, do the same with GLFW, but if I'm right... we've got a V. Yeah, we're okay with this one, are we? Yeah, we've got a library. You'd be fine with that. You can include that as a library. That'll work. That's okay. That dependent. I redid the GLFW so that you could do this, didn't I? Yes. Good on me. Well done, me. Pat on the back. So ImGUI's a bit tricky. GLM and SpeedLog are header only, aren't they? Yeah. They're fine. They're just includes. They don't count. They're not libraries. They're just header files that you include. So you just need pathing into this dependencies area so you can include them. Not difficult. Kept it as simple as possible, but that ImGUI one's a real pain in the backside to do, to set up. But good luck. At least I'm honest. So that's it, we're finished. That's shaders. Any questions? I don't expect you to reply to that question right now. I mean in the future. Okay? I realise that people aren't usually available to watch me live. And I know now that people are following these videos as we are getting comments on YouTube. I encourage you to do the same. I don't mind. It gives me something to do on my days off. And this coffee is lovely. So we're finished with this subject. We started with what? Conclusions? Any? Oh yes, go play. I really tried to emphasise that last time. So shaders filled out nicely. So I'm going to give you some advice now, which is the only good advice I can give. I've written all of this stuff on a blackboard. I am not politically correct, and I don't give a toss about anybody who is. And if you want to complain about what I just said, go shove your head up your arse. This is a blackboard. Okay, we've got lots and lots of information on it. Sue me. Okay, quite a lot of information on it. It's only just about able to fit on that screen. So during this week we've written all of this, but also there are manuals to all of the bits and pieces that we have been talking about. The only bit that there isn't a manual for is the system. There is a manual for your GPU. There is Chronos.org. .something. God knows what. There is a manual for your shaders. There is a manual for your GPU. There is a manual for OpenGL that will describe everything. There are countless resources on there for explaining how to program this. You don't need me to tell you. You do not need me to teach you. Go play. This system was the problem. You didn't know where to start was the problem. This is not the solution. This is my idea of a solution. Don't let it be your solution. Do your own. You may think, oh, but you've got 40 years experience doing this kind of stuff. Yeah, doesn't mean I'm right. Everybody's got a different viewpoint. Everybody's going to have a different way of doing this. And somebody is going to find a better way of doing it, and it's not going to be me. Why do I write this down? Because this isn't in the manual. Write it down, please, please, please. Get yourselves a program. Use Paint, use anything. Do what the hell you like, but write it down as you go. Because that will become your manual. When people say, go read the manual, and there isn't one because you didn't write it down, well, you're going to feel a bit of a pillock, aren't you? I'm lucky. I can't remember a damn thing. I have to write it down. I don't get a choice. You do. You can remember things, most likely, unless you've got a photographic memory and then you're screwed. You probably think you remember things. But please know one fact about the human memory. It can also forget. Mine can't. And that's why I can't remember. Make notes. You'll save yourself years. I've given you 40 years of programming in 5 hours each, 15 hours. From first principles. By the way, I started my first day out programming. Guess what subject I chose? OpenGL. Yeah. It's what I was interested in because I knew I wasn't allowed to write the AI program I wanted to write. So I chose OpenGL to distract myself quickly before I made a big mess of my life. I dropped it on the floor, didn't I? Yeah, I did pop it. How do I get to it? How do I get to the floor from here? Okay, retrieved. This was my very, very first subject. Do I have notes from my very, very first program? No, I do not. When I started out programming, I didn't make notes. And any notes that I have made are not my notes. They belong with the company that I worked for. They belong with the British government. Now you have my notes because I've written them in front of you. Up to you what you do with them. Ignore them if you want. Spend the next 40 years of your life playing with code. And as you retire and get wiser, you might start writing it down for the next generation. But I wasn't allowed to write it down for you. I had to leave my job to do this. I wasn't leaving my job so I could do this. The fact is that I had to leave my job for medical reasons. I wasn't always this disabled. Let's just put it that way. I think you get the drift. So, you've got my notes. You've got the videos, you can replay them. You can see how those notes came about. You can see the thought process now. You can disagree with what I've said. And that's important. It's important that you disagree and say, I can do better. Next week, we're actually going to do a study into programming at the request of our Karim. This weekend, I'm free. What do you want? I can do Bavarian tap dancing if you want. I could do a speech in Swahili. I can tell you why pigs can fly. Or how in reality hell can really freeze over. I can do anything. What would you like? I know I'm going to have fun. Let's have a look around. Something might come up in comments and decide on something completely different before tomorrow happens. So whatever happens tomorrow is going to be completely unprepared, isn't it? It's Saturday tomorrow. People might be able to not be at work and tune in. Oh, this could become interactive. Yikes. I don't mind. It's the chance I take. So tomorrow could turn into a Q&A on OpenGL for all I know. That'd be interesting if it did. I don't think people will have time to watch this before tomorrow. Never mind. I know 2 people are going to try. Oh no, they can't because I can't upload this till tomorrow, damn it. Never mind. So they won't know. So I can theorise on anything I like. Games clubs, games. What do we know? What have I been researching this last week? I don't really want to do too much more on artificial intelligence, as that could get dangerous. Monetization of a game we've already covered. We haven't covered a subject which is probably pretty important to this channel. Oh. Let's add it. We might be doing this tomorrow, people. Don't add that. If you're wondering why that keeps happening, it's because I'm trying to use my left hand on a keyboard and my left hand doesn't work. Get the right mouse. I'm not apologising for that. I'm just informing you. Okay, we can go from here. Put that to centre. I'll give you an idea of what we could cover tomorrow, because we've finished a request from a comment. That's the title. Could do that tomorrow. There's one we haven't done. Anything else we haven't done? We've covered basic principles of programming. We've covered the difference between programming and systems analyst. We've covered 3D graphics and mouse picking. Wow. Well done me. We've done OpenGL Mesh Loader and Editor with I'm GUI ticked. The code is there for you. The working code for that, by the way, is here at Avengers Amber Skies on GitHub. That's the working code for Windows 10 and Windows 11. You can probably shove this into Visual Studio 2019 and onwards, probably even 2010 and onwards, but it's up to you which one you want to use. Whatever floats your boat. Is this too big, or has it just moved? Interesting. Ah, right, as that green thing comes up. Yeah, it's there. Okay, it's just moved. So there's working code there for you. It's Windows based, so I'm not interested in it. I have no interest in programming anything for Windows at all. And damn, that coffee was good. Oh well, I guess it has to go now. Any other ideas that we can have up on our research board? Things you might want me to chat about? It's what I've been researching this last week is what makes a good game. So that's fresh well, not fresh information. It's research information that I've been gathering over the years. Do I know what makes a good game? Do I hell as like? It's research. We can talk about it. We can disagree about it. We can have a conversation about it, I guess. I'm not going to say an argument, because there's nothing to argue about. A game is either good or it's not. Is that just a viewpoint? No, actually it isn't. There is a definition for a good game. But there is an appendix to that now. Because my research took me to a place I didn't expect to go. And that's probably why I want to talk about it, I don't know. Research over the last week did anyway. It took me way, way further than I wanted to go. To complete the research, I had to suffer going through some flat earth theory, conspiracy theory stuff, which was quite interesting, so that I could get a handle on the viewpoints. It had nothing to do with the subject matter, it just had something to do with the presentation of the ideas and beliefs. And I needed to get my beliefs out of the way of the facts of what makes a good game. And to do that, I had to watch something which was based in belief and not fact. So, yeah, I chose Flat Earth. Sorry. I know a little bit too much about Flat Earth theory now. It's interesting. And I do have questions for them, which I would like answering. I do digress. But as I don't know any flat earthers, I've got nobody to ask. And I'm not inviting that to my channel. If you do want to talk about flat earth, you do not do it on this channel. Ever. You want to talk about politics, it's not coming in here, please. This is about games programming. It's the only place we're going to go. The rest will be ignored, deleted, or you will be taken down. Got it? Strict. Yes, I am. My community is protected. I protect my community. There's no free speech here, mate. It's my channel. Right, as long as we know where we're coming from. If you ever become under the impression that there is free speech on this channel, there isn't. My opinion doesn't matter. I will give you the facts. Anybody who comes up with conjecture, belief, or anything on my channel, God help you. But at the same time, I will listen. And that's a promise. But I won't judge, because I can't. I don't have the ability to judge. And that's why this channel is going to succeed in conveying the facts about what you need to program this, what makes a good game, what else was there? Research. We actually haven't talked about research, although we've got it as a heading. All right. Well, I think we need a heading then. Got you done. We're done. Done. Okay, let's get a new heading up for this one. Don't know when I'm going to do it. I'm planning the future of the channel here, folks. You've got a say in it, as you've already found out. I want to put it a bit down as well. Okay, we'll put it here. You might think that researching is reading the manuals. It's not. We haven't got a tick against that. We do have a tick over here. Good. Let's just tick this one as well. We have you open. That's supposed to be a tick. Complete. I have to know what's been completed, otherwise I'll lose track. Yeah, we've got a tick on it. Write code from scratch with more explanation. Right, we're going to do that next week. Over this weekend, we do have 2 subject matters now to go through. Is there going to be a Sunday talk? Do you like the Sunday talks? Do you want the Sunday talks? I don't know. Nobody's told me. We've done YQT and C++, a talk by Blades, Bugs, how bugs happen, the illusion of 3D and artificial intelligence, e-currency crept in as a side effect. This is what we've actually done. This doesn't need ticks. These are the talks that have happened on Sundays. Yeah, they can get a bit progressive, can't they? There's quite a lot here. Programming AI, how to measure IQ, illusion of 3D, bugs, we went through that. Verdict, get your act together, programmers. Oh dear. Did I get angry? Whoops. YQT, yeah, okay. I think that really discusses what QT is, rather than why, but hey-ho. It was a talk. We could go to employment, but then I'm going to get angry. We could do that as a talk for a Sunday. Did anybody follow up that e-currency little aside bit I did? I didn't. I should follow that up. Go and have a look at Axos. Or it's Axios, isn't it? That's a lie. I've done some research this week about currencies. NFTs. What time are we on now? 2? Well, we've already finished. You can switch off. It's okay. We're done for the day. Anything else that's on this today is about you and what you want. Shaders is done. NFTs came up on my research list this week. Anybody? Is that a talk? It comes under e-currency. Electronic currencies. Word of warning to anybody today who is thinking about investing in electronic currency. Bitcoin, NFTs, anything like that. My answer is don't. You'll lose your money. 100%. It will happen. If you think you can invest in it and make money, you can only do so if somebody else loses money. That's how that system works. You can't make money out of nothing. Money may be an illusion, but it has rules. It may be a fictional thing that we are making up, but it has rules. To have value, it has to adhere to those rules. Money cannot be created or destroyed. It can be invested and it can be withdrawn. To hold its value, it cannot directly affect its own value. Therefore, these currencies, these new electronic currencies, are worthless. Absolutely 100% worthless. It is a form of transferring wealth from one person to another. For everybody that wins, somebody has to lose. If you want to invest in the future of electronic currency, my conclusion is don't. NFTs especially so. They're even more dangerous than Bitcoin. Bitcoin is so damn dangerous it's untrue. NFTs are wide open. Don't even take me there. Oh, hacking! Great, let's go do something about that. How do we get there? This, yeah, okay, cool. How do I know whether I can do a talk on hacking? I have to look on the computer. Okay, let's get rid of that. Let's look on this computer. Let's see if I can do anything about hacking. It's an important subject. And I've just been reminded because I'm just looking at something that was about hacking. I'll need to ask the computer whether I'm allowed to do this. How do I do this? KVM? KVM might tell me. LVM? Yeah, okay. Oh, no, I don't want that. Quit. Try help. Alright, I'll try help. What do we got? Oh, LVM is the system for volume management for your hard drives. Alright. Wow. Look at that. Is there an exit function? No, doesn't seem to be one. Is there a quit function? No, there doesn't seem to be one. Is there a Control-C program? Yeah, there you go, Control-C. Right, let's not do that then. What do I need to know? I need to know whether I can use this computer for hacking. Alright, how do we ask our computer if we are allowed to hack? How's about install... Sorry. Let's go with Manjaro. How to install KVM, which is the kernel-based virtual machine system for Linux. Okay. Alright. I don't care. This computer doesn't matter to me. Now, I don't need to install KVM because I'm on a machine which I can wipe. The reason why I would prefer to use a virtual machine is because I've got all of the work from this series on here. So I prefer not to wipe it. I should back it up, I think, before I do anything like this anyway. Probably a good idea. You're telling me how to install it. And enable it. You've missed a step. No, this is wrong. You've missed the initial step. How to check if KVM will work. You've missed something. How do I enable? That's a file system. I don't want a file system. We've got an Arch wiki. Here we go. Hardware support. Requires that the virtual machine host's processor has virtualization support. You see, I told you they'd missed something. Named VT-X for Intel processors and AMD. This is an Intel processor, isn't it? Yeah, I've got an i5 here. So we're looking for a VT-X for Intel. The computer that I'm using to stream this is AMD, so I'd look for AMD V if I was to use this one. You can check whether your processor supports hardware virtualization with the following command. $ means sudo. Why am I calling it like that? Alternative grep. Okay. CPU info. Blah 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 blah. I'll try the top one. I'm not sure what it's doing in LC all. It's doing an ls CPU. That's the command. grep is usually better. Alright, I'm going to use the grep one. I trust that a little bit more. Let's try it again. Here we go. So that's the output. I've got a genuine Intel Core. Oh, it's an i7. I thought it was an i5. It's an i7-8700, 3.2 gigs. Okay. Stepping. Microcode. That's the actual megahertz of the CPU. 1133. Correct. The GPU is exactly the same, by the way. Interesting. FPU, CPU. Flags. What am I looking for? If nothing is displayed after running, well, grep will give you a display, you dirk. Then your processor does not support hardware virtualization. Does this mean it does? Oh, it's going through the processors. Processor 3, processor 4. VME. I don't see it. Okay. Processor 5, 6, 7, 8, 9, 10, 11. Okay, so that's all your processors. That's not telling me that LVM's this is available. That says processor 0. Okay. What else we got here? Let's try this. See what information we can get out of that. Virtualization. Virtual. No tab. Ization. Nothing there. Okay. Where? LSCPU. What is LSCPU? Where's the virtualization flag and what's it called? Why aren't you telling me in the wiki? KVM is not installed, so I can't do that. VMX unsupported. Doesn't mean it's not allowed. If I put this into the BIOS, I can't show you. There is a setting in the BIOS for your CPU, and that must be switched on for virtualization. It's usually in the advanced part of the BIOS, so I'm going to have to go and find it, aren't I? I can't show you that because I don't have a display for the BIOS. This obviously is not plugged into my display. It's coming through a program called ReCentral 4. ReCentral 4 is for my capture card, and my capture card will not work with this program unless it's inside of Windows. So if I am in the BIOS, which is before you load Windows, I can't show it because there's no driver. Clever. There's no display driver to show it with. Great capture cards. It says vulnerabilities. It's got an SMT vulnerable. Okay, fine for that. I don't care. I know you're vulnerable, mate. That's why I wanted to do this. I don't think it's switched on. Can we just clean up the mess I've just made, please? It's not showing. Where was I? I just closed it. Bollocks. Where was I? I was probably in projects. Twitch. There's nothing here. It was in reference. Yeah, there is an SLN. I would probably have been in Sandbox. You again. Every time you use Qt Creator, it seems to update the foundation.pro user. We got anything in Rana? Fragment, shaders, yeah, that doesn't matter. Projects Rana Twitch. Okay. Let's just have a quick look and see if I've made any differences in anywhere else. Like reference. No, we haven't. We haven't added any files. That's good news. I didn't save. Good. Just wanted to check that I haven't saved files out which we don't need. We can check here. That's looking okay. Yeah, everything's looking okay there. That's fine. Okay, I'm happy with the structure of my hard drive. I don't want to use KVM. Do I have to? What other alternatives have we got if we want to introduce security and hacking to our chats? Because I'm interested in it. I don't know if you are. And if you are going to do this kind of thing, having a virtual machine is more than handy. Plus, we also need a virtual machine to do operating system development. And to find out whether or not the program that we create and compile will work on somebody else's machine. Ooh. This could be very useful. A virtual machine can be more useful. This could give us a lot of material. Guess what we're doing tomorrow? I think we're looking at making a virtual machine. VMware. There's multiple memories for that. Can we just get rid of you altogether? Manjaro VMware. I only want core. Let me just browse core. Why are the workstations? OpenRC. Workstation. What the hell's that? Running multiple operating systems as virtual machines. What's this? The industry standard for running multiple operating systems as virtual machines on a single Linux PC. You are coming from here. Download for free, run virtual operating systems on one PC. The perfect tool for learning. Simple, powerful local virtualization, your path to work from anywhere. Safe web browsing in a secure sandbox. What happened to Oracle? Is this Oracle? Who's doing this? Who are you? VMware? Multi-cloud services for all apps enabling digital innovation and enterprise control. How are you earning money? Since our founding in 1998, our employees and partners have been behind the tech innovations transforming entire industries. Today, we continue to cultivate a culture of innovation where curiosity meets execution. Who's paid for all of this? Oracle, you are independent. And I know you are. These people are not. This is a business. Oracle, virtual machine. What's it called? Virtual box. Thank you. Well, it's here. Who's Oracle? Oracle is a company supported by the British government. Are they independent still, or are they dependent on the British government still? It's an org, it's a .org, you see, it's not a company, it's not .co.uk. That's a big giveaway. VirtualBox is a general-purpose full virtualizer for x86 hardware, targeted at server, desktop, and embedded use. For a thorough introduction to virtualization of VirtualBox, please refer to online version of VirtualBox user manual, blah, blah, blah. Oracle, contact, privacy policy, terms of use. Terms of use don't matter. Privacy policy, you don't care. Contact. Who are you? IT teams and solution providers. Who are you? Who are you? Just answer the damn question. I know who they are, it's okay. Do I trust them? Do I hell? I wouldn't trust these people with my credit card details. There's careers, developers, investors. Investors? So it is private. US sales. This should have been discontinued. Why are you still here? Blah, 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 blah. Blah, blah, blah. VirtualBox is being actively developed with frequent releases and has an ever-growing list of features. You were supposed to be discontinued. Supported guest operating systems and platforms. It runs on VirtualBox's community effort, backed by a dedicated company. Everyone is encouraged. So it's a free, open source community which develops a virtual environment. I don't want to download it. Terms are GPL version 2, you're safe to use it. And there are pre-built virtual boxes. .1.3.2. Sorry, downloads, go back. Platform packages, where's your GitHub? Older builds. Source code. Thank you. Oh, damn you, I don't want to download you. Pick off. Source code repository. Now we're getting to the truth. Is the one? I'm clicking on you. I'm not getting anything. Ah, gotcha. Last updated 2 months, 3 weeks. 3 weeks in documentation, includes and source and tools. Okay, 3 weeks. I honestly thought this had been discontinued. I was told this had been discontinued. this means that the community is continuing the development of VirtualBox. Oh dear. Oh well. I think the company has stopped its support. Okay. Financial, that is. I think it's community driven only now. Maybe that's the information that was sent to me. Okay. I'm with you. Why am I looking at this? Because Oracle I can trust about as far as I can throw them. But at least I have an ounce of trust. KVM? Not so sure. One thing I do know about VirtualBox is that it's probably bugged to hell and is very, very hackable. The source code is open source, so obviously anybody who wants to hack into the VirtualBox can probably do it. Why would you want to hack into a VirtualBox? I have no idea. Because that's the whole point of using it. You wouldn't run a business from a VirtualBox. You'd be stupid to do so. You'd use the cloud. And you're probably stupid to do that as well. Because the cloud is VMware. It's just another name for it, that's all. That's why I was interested whether the source code was open. And it is. I think KVM, I bet I could track down the source code for that as well, which puts you at the same risk. Alright. As long as I know the risk. It also means that I know that anybody using VPN or any kind of virtual mechanism to try and hack me has a big problem. Don't think you're safe. Because you're not. Alright, install. That was easy. Ethernet support. Guest edition CD. Yes, please. Server support developer kit. Choose. Oh, don't know. 5.4. Oh God, I think it's that one. Yeah. System. You're not telling me. That's fucking useless. Come on, I've got a hanging system here that doesn't really know what to do. No, I don't want that. No, 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 no. Kernel. Running and installed is 5.1.0. What options do I have here? Okay. 5.1.0 1051. Go back to the top. That says extra. Are all of these extra? No, community. Okay. Choose a provider for the host modules. Under community, we've got a host DKMS. I think we're under extra. I think we're here. That's the only one that matches what I've got. 3215. Can't tell. That's what I'm going to choose. Oh, great. Yeah, okay, apply. Go ahead. Make my day. Are we going to get an error message from that? Because I haven't switched virtual machines on. Interesting. Nothing's coming up on screen. As I said, I can't see until it actually gets into the window. So I don't know if there was anything in the logs. $15.11. Where's 15.11? 8th of April. Where's the 8th of April? 4th? 2nd, 3rd and 4th. 8th. Here we go. 15.11 just done. 15.10. Transaction started, installed. Yeah, you must load VBox DRV module before starting VirtualBox. Install VirtualBox, transaction complete, running 20. Yeah. VirtualBox should be running. Is it? Oh, it's there. That's correct. Was it really that easy? I didn't have to go into the BIOS and change anything. Is this chip, does it already have it switched on? Shall we find out? Shall we find out? Let's let's make a version of Manjaro. Manjaro is what we're already using. Check out our mini PC. See this mini PC idea? This is what the Apple Mac I have looks like. It's got an Apple logo on top, and it's a bit bigger than that. User guide, please. Yeah, I know, I can see you. I've come to some strange place which has redirected me to another strange place. Oh, bollocks to that. I'm not interested in being redirected all over the place, thank you, Manjaro. Oh, wow, we can have all of this. This is the software center. Ooh. Different ways to try it. Use it. Leaves your current system untouched. Experimental. Okay, using a virtual machine. Download an application that allows creating virtual machines and install it. We've just done VirtualBox. Create a virtual machine, set blah 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 blah. Alright, we'll come back to you. Loading, install Manjaro in blah blah blah. We need an ISO. Where's your ISOs? Where's your ISO? Oh, is it here? No. Download Manjaro. Hi. XFSCE. That's an interesting one. That's what we're using. KDE Plasma. That's rather nice. I like that one. That's my favourite, by the way. It's just that we're not using it. GNOME. Why use GNOME if Ubuntu uses GNOME? Just use Ubuntu. Maybe we should do that instead. Alright. XFCE it is. Minimal. Download minimal LTS. You'll do. Great, take me to download. There it is, ISO. No, don't open it. It's an ISO, you can't open it. Don't be so stupid. Create a virtual machine. It's here. There we go. So, VirtualBox. The left part of the application window contains global tools and a list. If this doesn't work, by the way, it means you might need to switch on through your BIOS, your virtualization thingy, because it may not be active on your computer or switched on. And some chips do not support it. So, yeah, there's that. Global tools and a list of all the virtual machines and virtual machine groups on your computer. You can import and create new VMs using corresponding toolbar buttons. Preferences, import, new. Cool. Two 2.5 gigabytes downloaded. You are in downloads. New. Okay, name. Caps lock off. No. Oh, right. Better. It was not K. It's X F C E, and this is basic. Type Linux. Version. (64-bit). Sugar, you're only doing 32. We're screwed. This isn't going to work. Memory size. Select the amount of RAM in megabytes to allocate to this virtual machine. 9, 8. Oh, that goes awkward. What's 8,008 times 1024? Don't know. We'll put it to the higher end of 8 then. 1024 won't be 8. It will be 8 2s are 16. 192 there is. That's my best guess. 8192. That should be 8 gigabytes of memory. How much have I got? More than 8 gigabytes of memory. Create a virtual, use an existing. Yeah, we'll create. Okay, create. There you go. VirtualBox we're using. I'm not going to be using anything else. Let's go with that. Dynamically allocated. That's fine. Gigabytes. I'll need a bit more than that, I think. We'll go with 100. Is it going to click to anything? Like 102. No, we'll go with that then. 103.38. That'll do. Here we go. So you want to go from an optical hard disk. Okay. Storage. Optical drive empty. That didn't work. Search by name, add. Optical disc selector. I will take you out of downloads, please, and I'll take you there. There's our ISO. We'll choose you. Right, we've now got the ISO loaded up on an optical hard drive, optical CD drive connected to this virtual machine. We do have optical as our boot. Network, fine. Audio, I don't really want any. USB controller, I'll hope that works. Start. Failed to open a session for the virtual machine. Excellent. Details. VTX is disabled in the BIOS. It now tells me that I need to go to the BIOS and enable the VTX, which is what I was thinking. I didn't think it was on by default. I can't show this, can I? On here. I'll have to do that separately. We're on 1526. Alright, so we can wind down if we want. I'll have to do this offline because I have to plug in this machine to a monitor. I can't run the BIOS from here. I have to put an actual monitor on it. Yeah. Clever, isn't it? Computers, they're so silly. The reason being, it needs a driver. And the operating system doesn't have a driver. The BIOS doesn't have a video driver. It just has the basic default video output display, which I can't pick up on. I bet it's under delete. I wonder if I could. We could try. It won't work, will it? I'll have to plug it into the display that I'm using to stream. That display goes in on that port over there. That lead can go across, but you won't be able to see it because it'll only be displayed for me. I'd have to do raw capture. I can't do raw capture. What are you seeing this through? Can I do raw capture? This isn't transmitting, this is just allowing us to see it. This is just I'm just using this as a portal through to the other machine. I have no idea what the base resolution is. It will be VGA or SVGA. Probably 800 by 600. Refresh rate. Video bit rate. there's not really much I can do here. It's not giving me raw. So I can stream using this. And I can multi-stream using this. Which I'm not going to do, obviously, because I've got my streaming device is my graphics card. That's why I chose an AMD graphics card, because the streaming software is actually hard-coded into the graphics card, and therefore it doesn't require me any processing power to run it. Here's the streaming software. It's in my graphics card. Big button. Display. I can't change it because we're streaming. Okay. So as you can see by the metrics, my CPU is not doing nothing. My GPU is streaming. And that's why I use AMD graphics cards. And it's the only reason I use them. Try on NVIDIA. Yikes. I would prefer not to. The lack of control is huge. There's not too much control on that either. I don't think I can get through. I really don't think I can get through. VTX disabled in BIOS. Okay. So it's all set up. Can I save this file? Does it automatically save? It's here and it's powered off. It doesn't look as though I need to do anything. Okay. I'm guessing it's a delete key. Power off, please. I need the title screen. I've got a keyboard. I've got a delete key. 1000, 2000, 3000, 4000, 5000. Switch on, mash your delete key. Computer is starting up. Hard drive is flashing. Loading, loading, flashing. It's doing something. And delete key didn't work. Therefore, it's probably not that key. I would guess then it's the other delete key, the one that doesn't say delete but has a full stop on it, and it's on the num pad. 1000, 2000, 3000, 4000, 5000, test. Mashing the other delete key. Booting. Loading. Oh. No. There's no boot to BIOS option. F12 and F9 are the other two keys that are basically used. F8 could be used. FE11 can be used. Anything from 9, 10, 11 and 12 can be used. I need to see the initial load up screen because the instruction is written across the bottom and we don't get to see it. I'll have to plug it into another monitor. I'm not going to be able to show you. Damn. So if you know how to boot into your own BIOS, that's fine. If you don't, and you don't know how to find that, you're going to get stuck, aren't you? Not something I can overcome. Not directly at this point in time. I must be able to set this up in a different way. How would I do that? Is there a pass-through for direct into my graphics card? How can I pick up from my graphics card? AMD, you're usually quite good about this. Don't need you open. You're practically useless now. Okay. Can I change to anywhere? You see, I've got it here. And it's the only option I'm going to be given. I could use a camera. Onto a screen. How can you record that? Does anybody know how I can do that? Other media HD capture. That's the wrong. Can we get rid of this? Please. It's in the way now. Yes, we can. Right. Don't need that mouse. That mouse is now dead. We're not using that machine. Okay. Was it all one word? Jesus Christ. I wish I had a memory. A capital V capital M HD capture. Weird. Me. They're just going to do that. Media HD capture. Question: how to capture the BIOS screen? How to take a screenshot in your motherboard BIOS? That's not quite what I asked. C985. I've got 573.1. It's not answering the question. Here we go. I think it's this one. Can I record the reboot and BIOS via AVamedia's device? Neither computer reboot nor BIOS setting does support any video recording. BIOS recording is not easy due to the resolution automatically changes, and our device needs to know and detect the exact resolution that is recording. This is the reason why we are unable to support it. I knew it was the resolution that was the problem, but why can't your device detect that? A graphics card can. Why can a capture card not? Would we need an external capture card? This is an internal one that plugs inside. It goes straight inside your computer, and it goes into one of the PCIe slots, and it's a big card. It does 4K resolutions, which is what I use, 4K resolutions. Would we be better off with a dinky little toy one that we can just use a pass-through straight into the computer? A BIOS capture card. Is there such a thing? See how research goes. Capture card. I'm trying to capture the BIOS screen from another computer and laptops. I don't get a signal until the computer loads into. How do I capture that? Linus Tech Tips. Oh, if you haven't heard of Linus Tech Tips, I do actually follow this channel for very good reasons. He also gave out some information which wasn't correct, and I was going to talk about earlier, and I didn't. Solved by the K-Dub, August the 12th, 2019. Read more. You might not be able to with a laptop. Try booting it and closing the laptop to see if that'll disable the built-in display and make it show the BIOS on the capture card instead. You probably can't capture it on that laptop. We haven't got a screen plugged into this, and the capture card won't support it. And you're looking Elgato. Okay, I know about Elgato. Point a camera to the monitor and record it that way. I've already come up with that solution. I didn't need to read you, dick. Will it be the cleanest recording? No. Will it be good enough? Very likely. Cameras these days have no issue recording monitors. Can't you just plug the monitor cable into the HD60 and start recording all the way from no signal? Answer, no. Please do your research before putting things like this on here. It needs to know the size of the screen. Isn't that in our boot log? I didn't look in Grub, did I? The boot. the bootstrapper for Arch Linux. I think it's 800 by 600 it uses. Can't quote me because I didn't look at it, did I? This is to do with HDMI. That's the reason they can't do it. It's because HDMI doesn't provide that facility. That's why they can't do the detection. Ooh. Could I set a display to 800 by 600 and then repass it through? I can. Do I have a throughput display? I'd have to have a standard input to a display, and the display would then have to go to HDMI and then into the capture card. That might work. What display have I got down here? Just one sec. Just going to have a quick look at the ports on a standard display. Oh, that's power lead. Oh, good. That's nice. Alright, this display that I've got here is an old Beano display. It's a little bit of a square block and was probably sold with an Acer computer back in around the 2000s. The monitor I'm looking at is old, and I choose these monitors because they do not have HDMI DMI ports on them. So they will display whatever the computer base motherboard will produce. It has a power input and it has one of these blue cables, old style cables, which... what are they called? I don't know. The old display cables, anyway, pre-HDMI. Let's just get rid of some of that dust. Eek. I think we might have to get rid of a lot of that dust. This hasn't been used for a while. It does have a cable though. Will I need a converter? Okay, I've got a HDMI to DVI adapter. It's not been opened. DVI is the American version, isn't it? Can't use that. What am I using on the brick down here, the monitoring computer? So there'll be something plugged into the back of this monitoring computer. I'll just take a look. That died. That's not got an adapter on it, so that is just a straight plug-in. What is the graphics card I've got in this? It's a 580, which will be NVIDIA, is it? An RX 580? What's an RX 580? Well, thank you, Linux. Oh, it's Radeon. Any ideas which one? That's the standard, isn't it? Where's the ports? Yeah. So it's a Radeon RX 580 colour vision is standard, isn't it? Doesn't Sapphire? I think I've probably gone Sapphire, knowing me. So let's go Sapphire. Let's go for the ports. If you're wondering why I'm looking it up and not just looking at the back of the computer, it's because it's in an awkward place. This looks familiar. Oh, there's an NVIDIA one. There's an RTX. No, that's a Versus. Give me the ports. Show me the back of the card. Ah. HDMI's. No, don't move. I didn't ask you to move. And it's one of those American thingies. Ah, we might not have an adapter for that on these computers. I told you I wasn't going to do anything on this channel without recording it. I do have a spare Linux box lying around. I also have adapters and spare cable boxes lying around. Just give me 1 second, I'm interested now. The spare box has a 480 in it, and that plugs straight in to this monitor without a problem. How do I get to see behind this machine that I've got down here? It may be possible if I move the chair. I am going to have to move the microphone as well, aren't I? Just 1 second, you're going to get microphone nasty noises. Yeah, everything's in the way. I can see a port, but it might not be the right one. I can only see it from a top-down perspective. Okay, there's a monitor. How big is the monitor lead and how far will it go? The monitor lead is quite long. A meter. It might actually reach. Just give me a second, I'll see if it'll plug in. No, it needs a DVI converter. Which I have. Someplace. Right, let's just bring you back down. Oi, over here, microphone. Come back. Thank you. Yeah, I'd need a DVI converter to be able to put it onto this monitor, so it's not going to get done today. I was wanting to get it done today so I could show you what happens next, but that's not going to happen. So instead of wasting any more time on this video, we'll go into that tomorrow. I'll fire this up, go and find a monitor that will handle it. I'd be better off with a HDMI monitor, wouldn't I? I've got one in the other room. I'm using it on the Apple Mac at the moment. I can just pick it up and bring it through here, can't I? So I'll go and get that monitor. I'll put this back into storage, this one. I'll throw it back on the floor where it came from. That's my storage. And I'll do it that way. Can we get this out of the way now, please? Okay, done. Everything's out of the way. Good. Can I mute? Ouch. Chair back. Ow. Sorry. My bad. That hurts. Okay, I accept. I don't give a sugar about you. Goodbye. You are the weakest link. Lovely. So, what have we decided to do tomorrow? It's looking like virtual machines tomorrow. We're going to have a play around on virtual machines. How about that? I'll switch the BIOS on after this, make sure it works, and we'll play with virtual machines tomorrow and see what we can do. we might be able to test out whether one of our practice pieces of software that we've made will run on a virtual machine. That could be honestly good. I'd have to log in. Who cares? We can log through to a virtual machine. We'll be alright with that. Not a problem. I know how to do it, I think. If we're lucky. So, virtual machines tomorrow. We've done everything else, haven't we? In the comments, I know that you might think, whoever asked for this, might think that I haven't answered the query fully, but we can come back to it anytime we want. We've got all the notes. So if there are more specific questions within this area, we can investigate this more. It's now an option for the Games Club. So OpenGL Foundation code as of now is closed, to be opened at your request and to be discussed further as you see fit. That's how this club's going to work. I'm not here to teach. Sorry, haven't got enough life left. Struggling. Good, as long as we understand each other. Thank you, phone, for your bling bling. I will look into that right now. We're 8 degrees, we're mostly sunny. Fantastic. Let's have a good day. Oh, what happened there? Alright. We're now live 4 hours. Average is about 5 hours. I'm happy with that. Everybody take care. I've messed around a little bit, showing you that how to choose VMware. Which one do you want to choose? Who cares? One that you might trust a little, maybe. But please remember, they are all bugged. They are all open to being hacked. Don't think you're safe if you're in VMware. Never be under that illusion. You're still on top of an operating system which is very, 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 very hackable. It's not the application you're using which is going to get you hacked. It's the operating system and the drivers. So, on that note, I'm not trying to protect you with a VMware. I just want to see whether we can have a third-party independent machine off the shelf from any store in the world. If we boot that up, can we run our software that we've made on that machine? That's important if you want to publish your software. That's what I'm looking at tomorrow, publishing software. Well, hey, we've got a title. Whoa, hold the phone. Where can we put this one? Press tab. Thank you. I'm going to go over here. Where? Right or left? There. I want 2.6 up here. And we'll pop it on that line there. No, it's not software. We're not doing software. And this is going to be test. And that's a topic. That's what we're doing tomorrow. Tomorrow's stream is about test, publish your game. We have a title, we have a way forwards, and we have an end to this stream that is successful. Thank you. I knew it would come out in the end if I just looked into something. You lot, keep making those comments. Keep doing that feedback. Let me know what you want. But don't you think it's important that you know how to publish what you've just made? I think it is. Take care. Have fun.